You spend hours configuring caching plugins, setting up CDNs, and tweaking image compression. But when you run a speed test, your time to first byte barely moves. The standard advice in the industry is to take an older server foundation and pile application-level optimization plugins on top of it. This means you end up fighting a slow setup, rather than starting with a fast one. Most performance guides focus on WordPress itself, completely ignoring the infrastructure underneath. Let's look at the baseline most optimization guides aim for: an expertly tuned Apache server running W3 total cache with a CDN in front. This comparison table shows exactly what that looks like. Even fully optimized, that Apache stack yields a time to first byte of 48 milliseconds. But a commercial web server called LiteSpeed drops that to 16 milliseconds before you configure a single caching plugin. To get that level of structural speed, you have to trade the free open-source server defaults for a commercially licensed infrastructure. To understand why the gap is so large, we need to trace exactly what happens when a visitor clicks a link on a standard Apache or nginx server. This flowchart tracks the request path, hitting Apache, initializing PHP, loading WordPress, and checking the plugin cache. Even with a perfectly cached file, the server still spends CPU cycles spinning up the application just to ask if the cache exists. LiteSpeed handles the exact same request differently. This parallel path shows LiteSpeed intercepting the request and serving the cached page directly from the web server layer. WordPress never loads and PHP never runs. That bypass creates what we call the performance floor effect. You get an instantaneous 16 millisecond baseline because the retrieval is happening in memory, right at the network level. But there is a strict trade-off. To keep that baseline, you must use LiteSpeed's specific cache plugin exclusively to tell the server when to clear old pages. If you install a traditional caching plugin like WP Rocket on a LiteSpeed server, you drag the cache check back into the PHP layer, erasing the speed advantage. Taking the cache out of WordPress and moving it to the server turns optimization from a constant effort to recover lost milliseconds into a pure structural advantage. Of course, full page caching doesn't work for everything. If you run a WooCommerce store or a membership platform, shopping carts and logged-in user sessions have to bypass the cache entirely. On Apache or nginx, every uncached click forces the server to cold start a new PHP process or cross Unix socket boundaries to generate the page. When a traffic spike hits, all those cold starts create a massive bottleneck. The server exhausts its CPU and memory limits, and the dynamic parts of your site crash, even if your static blog posts are loading perfectly. LiteSpeed solves this at the native level with a proprietary PHP handler called LSAPI. Instead of spinning up new processes from scratch, LSAPI maintains a persistent row of pre-warned PHP workers ready to process incoming requests immediately. The catch here is your hosting provider. To actually benefit from those faster execution times, your host must use strict resource isolation, so noisy neighbors can't drain your persistent workers. For dynamic sites, survival comes down to how efficiently your server handles PHP. In a high-concurrency e-commerce environment, that makes LSAPI critical. The exact same architectural logic applies to security. Let's look at how standard WordPress plugins handle a brute force bot attack. This chart illustrates the problem on Apache. To block a bot, the server must initialize PHP and load the security plugin. Workers quickly hit 100% capacity, rejecting bad traffic, locking out real customers because no PHP workers remain. LiteSpeed moves this defense layer out of the application and into the server itself with a built-in web application firewall. Here, the firewall intercepts, challenges, and rate limits the malicious bots before PHP is even triggered. The worker capacity stays completely empty. Add in LiteSpeed's native support for HTTP/3, which stops minor mobile packet loss from stalling out your parallel asset loads, and the infrastructure advantage compounding. You achieve true stability by stopping threats at the outer gate, preserving your internal processing power strictly for paying customers. LiteSpeed treats WordPress like a native application to be managed, rather than a generic folder of files to be served. This matrix plots budget against site complexity. Passive optimizers wanting out-of-the-box speed land in the commercial static zone for that 16 millisecond baseline. WooCommerce owners land in the dynamic heavyweight zone, solving PHP exhaustion. With zero budget, stick with open-source nginx or Apache. There is a catch to watch out for. Many hosting providers use misleading marketing, advertising LiteSpeed cache while actually running older Apache servers underneath. To verify what you're actually paying for, open your browser's developer tools, go to the Network tab, and check the HTTP response headers. If that header does not say Server LiteSpeed, you do not have the structural performance advantage, no matter what your hosting plan is called. Trusting abstract marketing claims won't make your site faster. Understanding the mechanics of your server architecture is the only way to make an infrastructure investment that actually pays off.